Good afternoon, everybody. Welcome to the afternoon session of the National Conference here at SVC Mysore. I would like to start off this session by welcoming Dr. Nancy D'Souza, Professor of Psychology, Maharaja's College, Mysore. Dr. Nancy D'Souza graduated with BSc from Mangalore University and with MSc post-graduation and PhD from University of Mysore in Psychology. He has obtained a diploma in biodiversity from the Inuyama University, Kyoto. He is working as a professor of psychology, Maharaja's College, Mysore. Dr. Nancy D'Souza has extensively worked on shyness as a thrust area of research. Also, he is working on addiction to social media and quality sleeping on students of both professional and non-professional courses. Dr. Nancy D'Souza has already published 250 articles in national and international journals. He is on the editorial board of 7 journals. He has edited 4 books on emerging trends in behavioral sciences. He has successfully guided 34 students in doctoral degree and many postdoctoral degrees with 25 students in MPhil degree. At present, he is guiding 12 students for a doctoral degree. He is the recipient of prestigious IPA President's Gold Medal Award in the year 2017 for excellence in psychology. He has been awarded Best Paper Award at both national and international conferences along with his co-authors. Along with his team, he has developed TUPG addiction test for the first time in the world. He has also developed tools on shyness assessment test, couple shyness questionnaire, shyness subtypes questionnaire, life skills questionnaire, and health and criminality proneness questionnaire. Dr. D'Souza has visited more than 35 countries in the world and has presented many papers and chaired the sessions too. He was the principal investigator of UGC-funded project on shyness. With this introduction, I would heartily welcome Dr. Nancy D'Souza to the National Conference here. The session is over to you, sir.
Good afternoon all. Today we are having workshop or conference. You know the meaning of workshop? Huh? The meaning of workshop is working shop. That means what? It is not that one person is going to speak there and you are just listening. So you have to actively participate and pose as many questions to the research person, so that you can have a high clarity on what is required for you. So please ask questions whenever you feel that there is a need for more understanding. Some of the concepts will be definitely new. So keep asking questions. You can stop me at any time because Madam has mentioned that is 4:30. So I'll try to stop by that. So starting with the first one, data analytics. When we talk about data analytics in research, it is not just data analysis. Please understand. It is not just data analysis. Data analysis is just part of data analytics. So what is the meaning then? So you are planning of research. Okay. Then meaningful way that constitutes data analytics. In a way, indirectly it gives the definition of statistics also. Third, how many of you are having a concept of statistics background? Because again, what we have done is, or what is our understanding is, statistics means analysis. Definitely not. Statistics is not just analysis, it is something more. So, a statistics has four processes. Because I am cutting down few of the slides because of the time restriction. It has got four processes: collection of data, compilation of the data, analysis of the data, and finally interpretation of the data. So, when we talk about the collection of data, the word itself, first word itself is data. What is this data? And there is no word called as data. Both data and data are used as well as plural. So, what do you mean by data then? Quick concepts, either it's a working shop. What is data? Data is information. Okay, much more specific. Required information. Okay, much more specific. Okay, data is a set of raw scores. Data is a set of raw scores. And what are these raw scores? The raw scores which you obtain is through what is called measurement. And what are those measurements? There are four levels of measurement, starting from nominal scale, ordinal scale, interval scale, and ratio scale. Have you heard of them? Research scholars here. How many research scholars are here? Research scholars. Nobody is raising hand. How is the group? MSc students. Okay. Okay. So definitely you must be knowing the scaling. Four levels of measurement, starting from ordinal level, interval level. There are four levels. So why this measurement we talk? Because later we are going to categorize whether the data is numerical or categorical. So in a way we are going to talk about qualitative data and quantitative data. Now in this group today's audience, approximately how many boys and how many girls are there? Roughly, I heard that there are 150 participants. So how many, roughly how many boys and how many girls? Or if you are offended by calling boys and girls, how many young adults are there? Okay. Young adult boys and young adult girls. Roughly, huh? 50 boys and I'm not going to check. Don't worry. So 50 boys or 50 boy young adults and 100 girl and young adults. Tell me, this is a quantitative data or qualitative data? Quantitative. Again, my question is, there are 50 young adults boys in this class and 100 young adults girls are there in the class. Whether it is a quantitative data or qualitative data. If you are telling quantitative data, you are wrong. This is where you have to start from scratch. What is this data part? Don't you learn in your brains? Definitely not. So the idea here is it looks like quantity, but what you are talking about the quality. It looks like quantity, but actually whatever I got 50 and 100, they are the frequency of occurrences. They are not true numbers. They are not true numbers. Why? Because when I said 50 boys, there are 50 boys having an entity of boys or males. The 50 such numbers repeat, whereas other side is 100. So that means it's not a quantitative data, it's a qualitative data. So don't get confused just by looking at the numbers. Because later when we talk about statistics, you have to be very careful. Data analytics. Are it clear? Now how quickly we switch off from quantitative to qualitative. So first understand the nature of data, what kind of data you have. Then when you talk about the collection of the data, I think you are doing a dissertation, fine. So when you talk about this dissertation and you are doing what you call data collection, few things are important. Are you going for a primary data collection or secondary data collection? I think most of you are going to a lab work only or something more. That's all inside the lab. So most of your research will be primary in nature. Why? Because you yourself actively involved in the data collection part and you analyze later. Whereas in the secondary data collection, somebody must have already collected the data and you take the what do you call that data from them and you recompile the data according to your objectives and hypotheses. This is the only difference. Suppose you want to know what you call the air index or air quality index of Mysore city for last 10 years. You don't have it. But there could be a meteorological department which has got this particular air quality index. You can go and collect the data and let it and compile what happened last 10 years. So it's nice. So the last 10 years what happened? Up to 2019 end of that it was going high. Suddenly there was a big drop in article. The quality increased. Then again after it decrease. Now you can say that the trends are very clear. Why that quality air quality index increased? What was that period? See, this was a corona period where even O3 zone improved. I don't know how many of you know that because I'm trying to give some chemistry examples. When the O3 zone started covering us, but what we are doing, we are back to the same story. What are you doing? Okay. So collection of the data is one of the important things in the part. The second part is the compilation of the data, where you have to set the data according to your objectives and hypotheses for the further analysis. That's the first, the next part. So it depends upon whether you do a manual compilation or Excel compilation or a software compilation, depending upon what is required for you. Then comes analysis, a major part in research, where analysis, whether you are going to use different types of analysis statistics. I will come to that. We are going to use basically three types: descriptive statistics, predictive statistics, and inferential statistics. All this will be discussing quickly. Once you analyze either manually through or through software, the last part is the big headache part is the interpretation of the data. So all these things are very important, and since you're all MSCs, since you're what you call, the idea is the title you have seen recent trends in research methodology. I'm going to give a lot of tips for your publication part. Because don't keep your work, just do your and keep it in the rack or that book will be permanently there in the principal's chamber and your home. No. How much that academic visibility you are doing by your work. Catch hold of your supervisors. Pressurize them to what you call be a co-author or you be first author and start publishing. Because the recent trend is okay in research is they say publish and flourish. If you don't publish, you perish. This is the mantra of today's research. That's a recent trend. So the publication will not come just like that. You need to put hard work. And I don't know how many of you are really planning for abroad because when you go abroad, when you apply what you call few of the universities, one of the component is a research component. What is your research contribution? So the more you start publishing now, it has got a lot of impact later when you what you call apply abroad and we have Southern Sir and we are all here. We know the importance of research. Even in India, even when you apply for some academic jobs, whether it could be teachers or professors or scientists, the first thing is they look into what is your research background. You cannot have just MSc in chemistry, no way. Along with MSc in chemistry, what is that you have publications. So start publishing. It will be in a smaller way, but definitely it has got a more openings for you when you come to what you call the higher levels of postings or even in research. And when you talk about the research, we are very specific. we are talking about the quality journals. So because nowadays there is all what you call after AI, I think money got what you call talk on AI backed statistics. Now calling AI backed research where AI can identify in what kind of journal you have published is a fake journal or a clone journal or it's really what you call a Scopus index or PubMed or at least UGC care if not try to publish at least in that what you say listed journals. The more you publish in that, definitely you have better scope for your job opportunities. Please do that. Not only in India, even in abroad. So this is the first thing I want to say. So that's what I'm telling. What you call to do that, you have to apply quality statistics. To publish article, you cannot just publish a journal article. So you should have a lot of stuff and that data what you have collected should be promptly analyzed in a specific way so that you can easily publish. Not an easy job. We know sometimes it takes 1 year time to publish in an international journal. 1 year. It takes 6 months for the what you call this one. The editor to correspond with the what you call reviewers or referees. So it takes really lot time. So that lot more time. So that's why you have to start working from scratch. So behind that background, types of statistics today we are going to discuss basically the first one, descriptive versus predictive versus inferential. We'll see what is descriptive statistics, what is predictive statistics, and what is inferential statistics later. So that's where we are going to discuss more. But one important thing is we are going to talk about parametric and non-parametric statistics. This is required. Why? Because when you talk about parametric statistics, how many of you know the difference between parametric and non-parametric statistics? Because based on the nature of the data, you have to apply statistics. You should know the nature of the data. Based on the nature of data, you should apply the statistics. You cannot simply apply statistics. Why? Because software nowadays we are all into software analysis. Nobody does manual. Nobody uses the simple calculator. Everybody uses the online software or offline software. Today I was supposed to give a demo, but because of the time constraints, I'm not using the demo. That's what I discussed with Guru sir. So we'll just build a theory part of it, but then I'll explain that. So when we talk about the parametric data, whatever the quantitative data you obtain, that is referred as parametric data. Quantitative. What is the qualitative data we collect? That is referred as non-parametric. So why we call this parametric and non-parametric? Now you tell me whether 50 and 100, whatever we call boys and girls, whether it's parametric or non-parametric. It is non-parametric, right? Okay, one part we are clear. Then what would be the parametric data? We call it as a continuous course. They are not categories. Suppose you are measuring what you call lead content in the air near industrial areas every day. So you can in terms of some numbers lead content because these industrial effluents will have lot of lead contents. So you can measure that air quality specifically on lead content. Then it will become a quantitative data. Now remember when we talk about why we are so specific because I don't have okay this one. When you talk about what you call quality, remember we have 50 boys and 100 girls. What is the total? 150 total, correct? No objection for that. How many genders are there? Two genders, 150 total. What is the average? 50 boys, 100 girls, total making 150. How many genders are there? Two. No LGBT, I'm not talking about that. I'm just talking about only male and female. Okay. So, two genders, 150 numbers. So, what is the average? 75. You are the only one person telling there is no average. But your answer is right. That's what exactly. So whenever you got a frequency data, you cannot have additional parameters. You can have additional parameters. 50 males and 100 females. You get the average by the statistics. Okay, software gives average as 75. Do you know what is the meaning of 75? By chance, if you do, an average of male and female constitutes what? An average of male and female constitutes the third gender or the transgender. So, my conclusion would be on an average in this class there should be 75 transgenders. So, be careful while doing such analysis. So, that is why I said we cannot average, we cannot have additional parameters for frequencies. So, that's just called a non-parametric, no additional parameters. Suppose you got a set of continuous scores like your own height or weight or your own HB measurements. So I can have average, all the measures of averages, all the measures of variabilities, minimum, maximum, range, sum, whatever. N number of parameters we can generate. So that is called as parametric statistics. And this usually comes from quantitative data. Whereas non-parametric, no parameters, it's only percentage or the proportion, but we're back to numbers only. That's why non-parametric. Talk about univariate and multivariate. If you apply one variable in analysis, it becomes univariate, and if you apply several variables, it becomes multiple. Basic process applied. Whatever you study inside the classroom, it will be basic. But when the same statistics you apply on a higher level and apply it on the societal level for a public utility, then it becomes applied statistics. The best example is midday meal program. There is a connection between statistics and midday meal program. Any idea? Especially in rural areas. Why this midday meal?
At least they can have one food.
Much more than that. Yes, one thing is what you call they can have food. Much more than that. What is the intention behind?
At least this is big.
No, where is the midday meal is given?
In school.
Schools. That meal to be given out. In your case, the meal can be given outside also. But why schools? Okay, forget about that. Okay, if there is confusion. Why bicycle scheme for especially for girls?
Give education to girls.
First issue, okay. Because remember, in rural areas there is a what is called bicycle freely given by the government for. I started with the girl child, later it's extended to everyone. And don't ask now what happened in Telangana Chittar. One case happened, so don't ask that. Okay. So once in a while there will be misuse of what you call such schemes. The entire bicycle scheme has come from a concept called as recreation. So this is something serious which you can also think of. Where? Much more than Vaidya concept earlier. So listen now, what happened? Now they found that female enrollment in the schools were very less compared to male literacy, what you call enrollment. Somebody started research, gave a project to some department, and then they found that, especially in rural areas, firstly schools are far compared to, and there are no facilities to commute. The second thing is girl child is involved more in domestic work, more in domestic work than the school work, and the attitude of the parents also. The girls are all outgoing, boys are all incoming, right? So for outgoing, why should we spend more? Okay. Now think of this. So domestic work, distance, and part of poverty, all this. So somebody gave a plan. Provide them a bicycle. So if they come to what you call school, once they have been provided a bicycle, they have to come to school. So two things are achieved in the same one. One is the girl child is educated, or the education of the girl child started increasing. the literacy rate among girls. The second thing is the punctuality of the girls or the attendance, overall attendance started increasing. And who gave? Statistics gave the answer, not in this one. Regression said yes. These are the things. These are the reasons for the girl child to become absent more. So increase this facility. Midday meal program. The child cannot just come to school and eat and go back. No, the child has to sit from morning to evening. Then only the afternoon food is given. Yes, the target is achieved because the child cannot come just for eating, so it has to come to school. Then poverty sub one part is over, attendance increased, education increased, and bicycle education was so famous. Later, it was extended to boys also and I don't know why Mysore is always they consider as a trial basis for many things. Okay, including the drill bicycle. Okay. But it's not okay. Cases first one. Okay, where we started in Mysore. Mysore is the big name for many new startups. Whatever it is. So I have understood what you call applied statistics. Then we start directly. What are the types of descriptive statistics which you can employ in a dissertation or in a thesis? The first one is graphical presentations. Now, remember, graphical presentations are required for descriptive statistics. Why? Because when you talk about graphical presentations, it's one of the alternative of what you call presenting data in a pictorial form. Why this is important? This is the descriptive statistics. In India, why graphical representation? Huh?
Much more easy to read. One thing is like after seeing the picture, they will know much more than reading. Like we have to spend a lot of time for reading.
By merely looking at the data, the inference may be little late. You have to read each one and then you have to decide. So, having graphics, the trends can be easily established and nobody is telling all these graphics look better than the numbers. All these pictures look better than numbers, right? Right or wrong? Entire our girls here, if you are putting lot of cosmetics, okay, it is because of the graphics. It is because of the graphics. Fair and lovely, 7 weeks. Have you seen the shades? Have you seen the shades? From dark to light complexion, fair complexion. I can challenge. Forget about 7 weeks. 7 years you could. But we still believe that because it comes with the celebrity endorsement. It comes with the celebrity endorsement. And you all science students, you know our complexion is based on our gene. The gene is responsible for our complexion, but still we try. Hold on. Okay, and it's a chemical. Okay, please don't use. Okay. It's a chemical. Whatever it may be. So that's what graphs looks better than numbers, and celebrities come. Okay, with a lot of changes in this one, and nowadays mail. Okay. Central tendencies. Okay, we'll just directly move on. Okay, types of graphical displays. You have as many numbers as possible. Bar diagram. Don't miss that bar. We take this outside BAS. These are bar diagrams. Then column diagrams, bar diagram, column diagram, and histogram, not histogram, histogram. That all through the box for the display. Frequency polygon or line diagram. Now you must have seen cricket matches. 20 overs India, then 20 overs another country. How it goes, the graph moves over to over. So line diagram. While floating of other lines, okay. Then cumulative frequency graph, that is when you connect one to the previous one, cumulative and later arithmetic. Converted to percentage is called as vocide, and a lot of this terminologies vocide, where you can have additional draw, median, and other things. Pie chart, where in a circle you are going to represent. Then scatter diagram, especially more specifically in the case of drawing regression line, x and y. Okay, what is the rate of change? Then pictograms. All those come through picture. Then area graphs usually used in geography and maybe partly chemistry, and there are many other types. So these are the measures of central tendencies. If you think that only mean, median and mode exists, no. There are 5 types of measures of tendencies are there: mean, median, mode, geometric mean, and harmonic mean. Depending on our necessity, we use what you call the measures of central tendency. Then we have got measures of variability. Okay, range, quadrant deviation, mean deviation, standard deviation, standard error, covariance. There are many. Okay, all these are used for measuring variability. So now I am giving a very specific tool for you. All your data analysis is based on the variability of the data spread. If we call it as heterogeneity and homogeneity of the data. In your case, if the data is more heterogeneous, please remember, if the data is more heterogeneous, you are bound to lose the significance. If the data is homogeneous, you are bound to get more significance. Now, what is this heterogeneity? The data spread is too much, the outliers are so many. So, once the data spread is too much, then we say there is a problem with your sample or there is a problem with the tool employed. So, if you have not used the right sample and the right tool, your heterogeneity of the data will be more and you are bound to lose the significance. If you use a what you call homogeneous sample, good tool for that age specific or the chemical specific, definitely you can do that. So measures of variability. Now directly we are going to start with the data analytics. So we usually talk about hypothesis and hypothesis testing, which will be done through predictive statistics as well as inferential statistics. Whatever it may be. How many types of hypotheses are there? Any idea? Any idea? How many types of hypotheses are there? In chemistry, you don't put hypothesis, or are you going to put research questions? Which one you are doing? At least you put objectives. No? After objectives, what do you do? Directly go for experimentation. Then you may be having the research questions, or you may be having a hypothesis. Okay, usually we talk about hypothesis because when we talk about hypothesis, understand this point. Hypothesis testing is very much required. Why? Because whatever you have done must be later verified and accepted or rejected at the end. Now, how many of you know the base? What is the basis for hypothesis formulation? You are all going to write dissertation, right? Madam, all of them are going to write dissertation, right? Huh?
No projects.
Okay, fine. For article also, remember when we talk about this, you should have hypothesis. Basically, we talk about 3 types of hypothesis: null hypothesis, but null hypothesis, alternate hypothesis, and directional hypothesis. Null hypothesis, alternate hypothesis, and directional hypothesis, where we don't talk much about directional hypothesis. Why? Because even the supervisors are scared to put directional hypothesis. Why? I'll tell you. So what is null hypothesis? Null hypothesis basically we say no difference, no relationship. No difference, no relationship. Because entire statistics will based on only 2 things. Either you talk by the difference or you talk by relationship. Only 2 things. Later there will be bifurcation. So a null hypothesis usually says no difference, no relationship. Alternate hypothesis opposite of null hypothesis. There is a difference, there is a relationship. Direction hypothesis. Now it's very specific. Where is that kind of difference and what kind of relationship? We start with the simple one in the present day situation. Okay. We start with the null hypothesis of academic achievement for gender. Boys and girls do not differ in their academic achievement. What I said, do not differ. Boys and girls. That's a null or no difference. How will it change now? In the alternative form? There is a difference. Our boys and girls differ significantly in their academic achievement. So where goes the direction hypothesis? Now we should be very specific. Huh? Okay, let's not go into the degree level. I'm talking about only SSLC and PUC. Talking about only SSLC and PUC. So even in 2024, I declare openly, girls are going to excel boys. What made me to tell this such a very strong level?
Statistical data.
We technically call it as review of literature. So for hypothesis formulation, please remember review of literature starts as a base. So review of literature, later you are going to write the chapter. It's not a waste chapter, but it gives a lot of information about what is being done and what is the proper directionality of the research. Why I said girls are going to excel? From my day of awareness of reading newspaper, not now. From my day of reading newspapers, I never saw this time boys excel. Whether it's in SSLC or in PUC. So my review is so strong, my backup is so strong, so I can easily say this year also, 2024 also, girls are going to excel. Don't feel bad. I'm also with you people. Okay. Now, think of this. This is from the difference point of view. Now come to the what you call relationship. Don't think about unnecessary relationship. We are going to talk about statistical relationship. Okay. Now when we talk about the relationship, one thing is important. So we talk about some dependence of one variable over the other variable. So what is that? I'll give again an example. Extent of Android usage, non-academically, and academic achievement are not related to each other. That means what? Any number of hours you use what you call Android, it will have no effect on your academic achievement. No relationship. How we say now on alternative form? Extent of Android usage and academic achievement are related to each other. How will you come to the directionality now? Now it should be very specific. As we said, girls excel in the previous difference. Now we have to be very specific. What happens? More the Android usage, lesser the academic achievement. It's proved also. More the Android usage because you don't get time to study. That is the problem. So, more the Android usage, lesser the academic achievement, or there is a inverse relationship between Android usage scores and academic achievement scores. You get the point? Why? Because of the Android usage, we don't sleep properly. Lot of time is wasted on Android or electronic gadgets. We are into gaming, we are into rummy circle, we are into varieties of things. Be careful, I was talking to madam. Nowadays NCRB started tracking what you call the child porn watchers and punished for 2 years. Okay? I haven't seen in article newspapers and all. Now NCRB started tracking your mobile data, which one you are watching. Be careful. Okay, whatever it may be. So higher we are into the Android usage, lesser will be the academic performance. Are you clear? So one of these hypotheses you have to you have to formulate if you are doing that. Then you have to clearly state, you know the problem, what you want to study. Clearly state the null and alternate hypothesis, including direct hypothesis, but you cannot put all the three together for one. You can do one of them. Then once you collect the data, now you have to check what kind of testing you are going to do. You have to apply what is relevant test, parametric or non-parametric. Then you apply a test, critical value comes from the table or the critical value comes from the software by itself. You have to determine the significance level, 0.95% level or 0.05 level. Out of this 0.01 level or 99% confidence level, you have to find out with the degrees of freedom. And one tail or two tail test. So when you talk about the two tail test, it's basically for null hypothesis and alternate hypothesis. For one-time test, we usually talk by direction hypothesis, means we are having a specific directionality. Then compare the test statistics critical value. You have a critical value, set value, and you have to compare with that. And if the value is more than the test statistics, then you reject the null hypothesis. If it is not significant, you do not reject the null hypothesis, accept the null hypothesis. But remember, another tip for you, null hypothesis when you formulate, they are meant for rejection. Please keep in your mind, when you formulate a null hypothesis, it is meant for rejection. When you formulate alternative or directional hypothesis, they are meant for acceptance. By chance, if you are forced to accept the null hypothesis and forced to reject alternative or directional hypothesis, you are committing two types of technical errors called as type 1 and type 2 errors. Now go back to the journal publication. The more type 1 and type 2 errors you have in your article, they'll send you back. Your article will come back because more type 1 and type 2 errors means what? The quality of your article is not good. It will come back. And again, I am coming back to the publication part. The topmost journals in the world, the acceptance rate less than 10%. If you send 100 articles, only 10 are published, 90 will be rejected. So such a rigidity they have. That's why the journal qualities are. Nature now we cannot even think of. Okay, nature, science and all, we cannot even think of. Because many times the editor will not even send a review. Editor himself, if it's not up to our standards, he'll reject. That also can happen. So having this background, now we start with the what you call test part. So we start with the four types of testing in research. Four types. One is parametric difference, and then the parametric relationship. Another one is non-parametric difference and non-parametric relationship. Under four headings we are going to do. So the first one is four types. One is parametric difference because we said entire statistics is based on two levels, that is a difference or relationship. Under that we subtype parametric and non-parametric. So we start with the what we call parametric difference. So when we talk about the parametric difference, remember we are going to talk about the quantitative data, not the qualitative data. So we start with the parametric difference. So when the difference you think of, you usually expect two groups difference. Otherwise, how do you establish a difference? So two groups of minimum you want to find out the difference. So whenever you have a two group difference, please make a note. It will be invariably a t-test. It is invariably a t-test. So it's a two group difference. So what is it?
AVUL.
Okay, so two group difference. So there are three types of t-tests are available. Three types of t-tests. So independent sample t-test, paired sample t-test, and one sample t-test. So there are three types of t-tests are available. So first is independent sample t-test. So in independent sample t-test, what we do is we try to establish a mean difference between two groups. A dose of 0.1 ml, a dose of 0.5 ml, treatment for microbial killings or microbial this one. So now you have two different groups, and what is the mortality rate? You can apply a simple t-test and technically called it as independent samples t-test. So next one.
Estimates.
So you have three types: independent samples, paired samples, and one sample t. But please make a note: independent sample t-test will be applied when your sample size is less than 30. If the sample size is less than 30, then only you apply independent sample t-test. Otherwise, you have to go for a Z test. You have to go for a Z test. So the independent sample goes by other names also, like unpaired t-test, student t-test, two samples test, whatever it may be, but you try to establish a mean difference between two groups drawn independently. That is called as independent samples t-test. The next one is paired samples. So when you talk about the paired samples t-test, the idea here is, okay, you have a single sample but exposed twice. It is exposed twice. Same sample exposed twice. For example, how many of you know before and after design or pre-post design? Or you have kept something for a treatment. So before treatment and after treatment. You have two sets of data on the same material. The same container you have before and after. So suppose you have got 10 containers. Now you can apply a paired sample t-test. Means what? Sample is paired for a particular variable. Are you getting it? So the measurement can come from either simultaneously or successively. What is successive? One after the other. Today you give for a treatment. Before that you have measured pre-measurement. Later, after what you call one day you again you measure the same variable. Now it is pre-post. Or the best example from medical side. Blood pressure measured today, tomorrow, day after. So it is a repeated measurement. So if you measure any two, comparison any two, then becomes a paired sample t-test, but on the single subject repeated. So that will be 10 subjects. Same subject has to be exposed twice, either simultaneously or successively. Then only it is called as paired samples t-test. Then comes one sample t-test. And many of people they don't know the advantage of one sample t-test. So in one sample t-test, what you do is you compare your group mean against an established standard mean. Are you getting my point? You compare your group mean against an established standard mean. So idea here is like again going back to the medicine. Usually give the example of a doctor. Suppose if you go to a doctor for some issues, I expect not to go. What is the doctor? What is the duty of the doctor first? Don't ask the nurse. Doctor. Okay then. Huh? What is the first job the doctor does? Huh? This is the first, right? And after that, he have only two judgments. What are those two judgments? He has only one of the two judgments. What are those two judgments? Either you are okay or not okay. Only two things. Later he may feel your pulse. That's a very different thing. But first he is going to feel your pulse, not the pulse. Okay. Now come back to this. How he said either you are okay or you are not okay. Remember, a doctor will not have a healthy individual all the time comparing like this. Okay, there is a problem. No, he will not do that. By just doing a single check, he says there is a problem or there is no problem. Why? Because the doctor can easily make out the pulse rate, which is 70272, which is a normal rate, and if it goes above, then he says okay, there is a problem. If it goes below also, he says there is a problem. So now you have such people. So lot of data is there. You don't require any control group because what is the control group? The same values will derived from the control. So the standards are already there. So you check your group mean against the standard. Now it becomes one sample t-test. So there are two groups. What are those two groups? One is your group and one is the standard group. So you have three types of t-tests: independent samples, two samples drawn randomly from the population, paired sample, same sample exposed twice, either simultaneously or successively, or one sample T where you compare your group mean against a standard mean. Are you clear about this? And Z test I have put there. So that means what? If the sample size is more than 30, don't use T test. Use Z test. Go back to the journals. Why your article comes back because you have used Z T test instead of Z test. Are you clear about it? Suppose if there are more than two groups are there, what are you going to do? When there are more than two groups are there, they are going to use another technical word called as ANOVA. What was it? One ANOVA, two ANOVA, MANOVA, ANCOVA, RM ANOVA. Not RM ANOVA. Okay. RM, repeated measure ANOVA. So, now quickly have a browse over it. ANOVA stands for full form is analysis of variance. Go back to homogeneity and heterogeneity of the data. SB is standard deviation, square of that is variance. Sigma into sigma is the sigma square. We analyze the variance across the groups. We analyze the variance across the groups, and then what we do is we try to establish a mean difference. But the idea is here there should be minimum of three groups independently drawn. If there are two groups, you are back to paired independent samples t-test. Here there should be minimum three groups to perform ANOVA, and the other way is called as F test. How many of you know full form of F, not frequency? What the full form of F? Huh? It's Fisher. Because the person who identified this entire what you call calculations was Ronald A. Fisher, and his disciple. One should really appreciate. Fisher was not interested in keeping his name, but his Shishya or disciple, Snedeko, he kept his what you call guru's name Fisher's test. Let me see after doing a lot of chemical experimentation, how many of you keep your guru's names? Okay, specific test. That's the group of C. Okay. One way over. Okay, one way over. Three groups compared simultaneously. So group 1, group 2, group 3, or dosage 1, dosage 2, and dosage 3 against the entirety. So you have three groups. So once you have got three groups, you can compare across them to find out whether the groups differ in their variability as well as in their difference. Now it is one way ANOVA, nothing but extension of independent sample speed test. You can do three tests, 1 to 2, 1 to 3, and 2 to 3. But all this can be avoided by performing a single one way ANOVA, where I am going back to independent and dependent variable. One independent variable is split into minimum of 3 levels: group 1, group 2, group 3. I increase the complexity. So when I start tackling increasing the complexity, now I say two-way ANOVA. So what is two-way ANOVA? Two independent variables versus one independent, one dependent variable, two independent. So the entirety group 1, group 2, group 3. Now I put temperature below 20 and above 20. Now it becomes two-way ANOVA. I applied another statistic called as two-way ANOVA. Your independent variables are split into what you call twice in a different levels. First variable is 3 doses, that is 3 design. Second one is 2 levels, less than 20 and more than 20 temperature. So your research design would be 3 by 2 design, because the first variable is split into 3 levels, second variable is split into 2 levels, thereby making a design of 3 by 2. You can keep on continuing 2 ANOVA, 3 ANOVA, 4 ANOVA, but all together they are called as univariate ANOVA. Why univariate ANOVA? Because you have got a single dependent, that's a univariate, versus two or more independent variables, that is called as univariate. Next one, multivariate. When you talk about multivariate, remember you have multiple independents and multiple dependents. And remember why we are talking about the multivariate analysis, because of this. You have got several independent variables, several dependent variables. Perform MANOVA, make a good interpretation, definitely it will be accepted. But many times problem is we don't do MANOVA. We do just do ANOVA and send it. They say this can be better fit for MANOVA. So what it may be? Multivariate ANOVA. And remember, whenever you represent MANOVA in your what you call article, don't forget to mention, make a point, Wilks lambda, WILK apostrophe S, Wilks lambda in MANOVA to be given very specifically, or otherwise they don't accept. So Wilks lambda, this index gives the overall effect of all the selected independent variables over the dependent variables which are selected. So you got multiple dependents and multiple independents. Repeated measure ANOVA. We talked about the blood pressure or the chemical treatment. Day 1, day 2, if it's only 2 days, paired samples. Whatever day 1, day 2, day 3, day 4. So over the days, in a particular field, what is happening? Now instead of going for paired samples several times, you can go for a repeated measure ANOVA over the duration. What is happening to a particular variable? Uncover, something suddenly C entered. Analysis of covariance, any idea? I'll give a simple example. One of you thought, okay, I would like to measure what you call stress and anxiety among India's capital and Israel's capital. You know why? So, one of you took this what you call initiative, went to Delhi, collected the data. Same person went to Tel Aviv, that's the capital of Israel, collected the data. Structured questionnaire we use, best statistics you have used, methodologies matched, age groups matched, gender matched. You have done the analysis, the best statistical tools applied. You send the article to the journal, and what was your finding? Israel people have got higher anxiety and stress compared to Delhi people. You have applied a simple statistics ANOVA with the gender difference and all. Now the article comes back, reconsider your analysis. Why? What made what you call the general people to send the article back? You have measured the same tool, you have given the same what you call timings, age groups matched, gender matched, best statistics applied, no loopholes in the what you call data collection part, but still the article is about to reject. Why?
The situation here in Israel and the situation in London is different.
The first thing is there is a third variable which is affecting the entire scenario in the Israel. So that is what? The scenario. Now, such variables we call as a confounding variable or intervening variable. I'll come to a technical part. Intervening variable or extraneous variable. Now, when they influence the outcome of the results, we cannot apply a simple ANOVA. We have to go for UNCOVA. You have kept what you call some what you call experimentation for 24 hours, happily gone and came back after 24 hours. No change. You report, it comes back. There was a problem. There was an electricity problem. So there was no electricity, so that there was no reaction happened overnight, and you get the same value, which is a technical fault. And this is called as intervening variable. What is intervening? Something which is unnecessary, which has been introduced in the experimentation process, and thereby it has changed the end result. It is not a catalyst. You know what will become a catalyst? Either it increases or decreases, but it will not affect the end result. But here, in this case, the extraneous variable will affect the end result. In such cases, don't apply ANOVA, go for UNCOVA. So quantify that variable, treat it as a covariate, and go for UNCOVA or analysis of covariance. Then comes what you call post-hoc test. So when you talk about the post-hoc test, remember F test when we do when there are more than two groups. So there is three groups A, B, C. So when there are three groups A, B, C, we don't know whether the difference exists between A to B, B to C, or A to C. So the post-hoc tests are used for multiple comparisons. So please make a note. Post-hoc tests are used for multiple comparisons so that which of the individual comparisons are significantly different. So that is more important. Individual comparisons. So there are several such what we call tests are available. LSD is not necessarily as diethylamide. No, LSD is the least significant difference. Then there are several other tests, Johnson's multiple brain tests, Pancaroni, Dunnes, cookies. There are many tests are available. Sheffield's tests available. So all these tests will indicate which are the individual comparisons are different from each other. But for your information, never use LSD or DMRT. The first two, again, journals will not accept. The good journals will not accept the first two, LSD or DMRT. Now comes parametric relationship. So when we talk about the parametric relationship, usually we talk about what is correlation? What is correlation? When we talk about correlation, it is the dependence of one variable other the other variable. So when there is a quantitative data is there, quantitative I'm underlining, quantitative go for Pearson's product moment correlation, and the correlation might range from -1 to +1. The correlation might range from -1 can go to 0 and end up with a +1. If at all you get correlation more than 1, that means you have done definitely something wrong. So now there are different types of correlation. This product moment correlation. Decide whichever you want. That will be product moment correlation. Sometimes the partial correlation. What is the partial correlation? Same concept. When the extraneous variable or the intervening variable or confounding variable will have influence on the correlation. Don't use a regular correlation. Use what we call partial correlation. Why? Because when the existing relationship between two variables being affected by the third variable, you also use that terminology. In statistics, we say spurious relationship, you say toxic relationship. Okay. When the existing relationship is being affected by the third variable, okay, or fourth variable, then we end up in a spurious relationship, and you can use that what you call word, don't use the word toxic. Statistics, you don't use the statistics, use the spurious relationship. In such cases, you have to use for a partial correlation, partial of that effect. Then comes regression. What is regression? One step ahead from the correlation. If correlation gives the mutuality between two or more variables, regression gives the extent of change. If x is increased by 1 unit, what is the corresponding change in the y? If Android usage is increased by 1 hour, what is the corresponding decrease in your academic achievement? Or if you reduce your Android usage 1 hour, what is the corresponding increment in your academic achievement? Are you getting the point? So that constitutes the regression. There are varieties, simple regression and multiple regression. Then comes non-parametric side, difference-based test. We start with the chi-square test. Now go back to 50 and 100. The first we started. For this we can apply chi-square test. 50 versus 100. Whether girls really outnumber boys. In such cases you can apply a chi-square test for frequency of differences or difference between the frequencies. You can do by a chi-square test. Then man-Whitney U test. Now remember an important thing. Before you subject your data into any statistics, please, even for in the future, check your data for normality. Check your data for normality. Why normality? Because sometimes the data is not following the normal probability curve. Okay. Anybody has read about normal probability curve? More data should be the center, and as you go towards extremes, the data should be less and less. So that constitutes a normal probability curve when, and that will be set by two of the tests. Which are those two of the tests? I just show those tests. Please have a note of this. One is Shapiro-Wilk test, and one is Kolmogorov-Smirnov test, not Smirnov. Both are Russians. Okay. Smirnov and Smirnov. What will it do? It's a Smirnov. So when your sample size is less than 50, you use Shapiro-Wilk test for significance of normality. When it's more than 50, you use Kolmogorov-Smirnov. But in both the cases, your test value should not be significant. That is very important. So, come back to this. So, two groups difference. Normality is not there. Your data is parametric. Go back to this one. Quantitative data, no normality. Automatically switch over to non-parametric side. Man-Whitney test for two groups differences. Wilcoxon sign rank test. Where sample speed test there? Wilcoxon sign rank test here. As there is a table there, letter is there. 1 man over there, crystal value is 1 man over here. Of course, the test pattern is different, and non-parametrics works on only ranks and signs. No original scores are employed in non-parametric statistics. Original scores are never used, either ranks or signs will be used. So, crystal value is 1 man over. Then comes, even in non-parametric side, there is a relationship. Spearman rank correlation. There we talked about Pearson's product moment. Here we do a rank difference. Contingency coefficients. When you got your cross tabulation 2 by 2, 3 by 3, 4 by 4. When the number of rows are exactly equal to number of columns, then you can use a contingency based analysis. Frequencies are employed. Whether columns are contingent upon rows or rows are contingent upon the columns. Travers-Lee, another test, where an unequal number of rows and columns are there, go for Travers-Lee test. Then there is a mixed regression, binomial and multinomial logistic regression. I am going to ask you, suppose you want to check what makes you happy or what makes you unhappy or sad in Sharda Vilas College. Random question. I'll start with the first one. What makes you happy about this college? Okay. How many of you part of this college? You know. Okay. What makes you happy about this college? The faculty. Congratulations, madam. The faculty is okay. Faculty, because of the faculty, good teaching. Okay, I don't know that because of the new marks. Okay. Huh? Okay. The teach well. Good. Okay. What makes you happy? This college. You don't know. You are not from this college. Good lab facilities makes her happy. Huh? Teaching is already done. Any other thing? I am going to ask boys very different question. Okay. Huh? Clean lab side, classroom. What makes this? Huh? Supporting, motivating teachers. Very good. Okay. Boys, what makes this college sad? Huh? Too many seminars. makes you happy? What makes you unhappy? We cannot apply any regular statistics. We have to apply logistic regressions. That is a very good feedback for your principal, not now. After if you do the analysis, she'll come out or the analysis will give her a big idea. These factors makes the students happy. So improve more upon that. These factors make the students more unhappy. Decrease those intensities. Automatically the college standards increase. Now in such cases we use the logistic regressions. Varieties we can do. So that's the idea. Now, there are more what you call advanced analysis. So I just can I indicate them. What you call the first one is the factor analysis, where it gives a lot of idea about deriving the components. Don't worry about now. Then there are discriminant function analysis. Suppose you want to make two distinct groups or three distinct groups based on different qualities. For example, a group from South India, a group from North India, a group from Northeast, and takes lot of chemical what you call parameters, see whether discriminate between each other. There could be differences, right? There could be differences, right? If there is a race difference, why not biochemical differences on a minor level? Structural equation modeling, the new trend in research. What is structural equation modeling? You have a cause, you have an effect, but there is something mediating in between. You have a cause, you have a effect. Now what mediates? The best example will be, best example as I want to say, particular type of personality is more prone to suicide. They may not commit suicide, they have more suicidal ideations. But what prompts them, what is mediating them? The web series or the media. So how much does media has a role in increasing the suicidal tendency with a specific type of personality? Because we are into web series today, right? Family Man waiting for the season 3, right? 4 more shots, please. Now remember, where are we? And how many web series? Vanilla, a murder series, and how many of you see? Right? Seeker, the boys went crazy, the command. Okay. Whatever it may be. Now those things might what you call mediate along with an introvert personality with the specific type of web series giving such ideas can have more increase in the suicidal tendency. Again, I'm not saying they commit suicide, no. Suicidal tendencies. So all these things can happen. Now, important consideration before you do any data analysis. The first one is before testing any data, check for normality. If you don't check the normality and send for the publication, it will come back. So check for normality is the first step. Second one, data is not following normality. Apply non-parametric tests like bandwidth TU and all those things, not the regular independent sample test. If the data is not following normality. Next one is sometimes the data will be very less in chemistry. Don't apply parametric test. Though the data is parametric, why? Because a small sample is not representative of the big population. A small sample may not represent the population, so don't use any parametric test. Use what you call non-parametric test. See the last point. If the data is less than 5, don't apply any statistics. Just give the descriptives. Mean and ST or frequency and percent enough. Don't use any statistics, inferential and all, because it is like abusing statistics. It is like for a mind, body pain, you are taking antibiotics, thinking that it's a fever. So don't abuse statistics. Significance levels, which were interpretation part of it. So we significant levels are interpreted based on 0.5, 0.01 and 0.001 level. Researchers and dissertation, whether it's what you call project works, this is very important. When you talk about the interpretation part, usually talk about 0.05 level or 95% confidence. That means what? If you repeat the experiment 100 times, 95 times you should get the same result and 5 times you can miss. So this is the surety of your results. So if the statistical class credit is 95, not 35. How many of you know the meaning of 35? First marks 35, right? Mass marks are 35, right? That means what? Even if you know one third of it, you are eligible. You know about it. Even if you know one third of the subject, you are passed, which is high, definitely wrong. But in statistics, no such chances. It is 95 out of 100. Then goes 99.01. What is also changed? Highly significant. If you repeat the experiment 100 times, 99 times you should get the same result. One time only you can miss. What changes? Highly significant. Furthermore, very highly significant. That means what? If you repeat the experiment 1000 times, 999 times you should get the same result. That means it is VHS, very highly significant. Now imagine how it changes. And this is what is looked on the general point of view again. So this is for alternative and null hypothesis. For direct hypothesis reduces by half. Please keep in your mind. Verification of the hypothesis is important in the data analytics. You have done null hypothesis or formulated. Your results are significant. You reject the null hypothesis which is expected. Because in the beginning we said null hypotheses are meant for rejection. But you have formulated null hypothesis. Your results are non-significant. You said no difference between boys and girls. You getting no difference. That is what you are accepting what you have said. Reverse is true for alternative and direct hypothesis. You use alternative direct hypothesis. Your results are significant. You accept. Results are not significant. You reject. These two are accepted format given in science. You are supposed to reject the null hypothesis. You are supposed to accept alternative or direct hypothesis. By not doing so, you are forcibly accepting the null hypothesis, forcibly rejecting the alternative or direct hypothesis. Thereby, you are committing two types of technical errors called as type 1 and type 2 errors. Again, I am telling more type 1 and type 2 errors will spoil your analysis and no person of publication. Now, what is the type 1 and okay? This is the table. Later you can correct. What is the alternative test you can use? Okay. Type 1 error. We also call it as bogus alarm effect. What is that bogus alarm? We are here now. Suddenly fire alarm comes. What we are going to do? We run and we evacuate. Madam calls, come, no fire. Something which has not happened. You report it as happened. Type 1 error. Are you getting my point? The next is there was no fire. There was fire, but no alarm. Type 2 error. There was fire, but no alarm. Now think of a patient with HIV on the medical side. A patient doesn't have HIV, but the test shows he is HIV positive. What can happen? There's another case. Person has HIV, but test says no. What can happen? So, type 2 errors are more dangerous than the type 1 errors, but in both the cases, whether the type 1 or type 2 errors, you have to avoid what you call the technical errors, both type 1 and type 2 errors. Anyway, and then the type 3 error. This is from the researcher side. This is not from experiment side or testing side. Okay, type 3 error is from who? From the researchers. What is that? Lazy. You have to go to Ukraine Lake and collect the water sample. You will go there. Somewhere collect here on the Shasal. You are supposed to go to another lake, Dalwai Lake, or somewhere far off village side lake and collect the water sample and identify the biochemical properties of them. You collect somewhere some better gear itself. Lazy. Incompetent. You don't know how to do it. Third part, willful ignorance of the truth. What is that? Instead of using, if you know that if you use this sample, the results will be spoiled. Don't use that. Throw it out. Willful ignorance. And sometimes project work from the commerce people. Please remember, the data collection happens in hostel or PG. All night the data collection happens. You are supposed to go to Patna and collect the data. Supposed to go to Headband Industrial Area and collect the data. The data collection happens within the room with so many friends. Please don't do that. Willful ignorance of the truth, trying to what you call divert. That's why the quality of research comes down. All those things. Okay. So with this, I'm concluding the talk because already the guests have come for the valedictory session. And before the end, if you have got any doubts, feel free to ask. Any doubts? Huh? Not all the tests. Depending upon the nature of the data, objectives and hypotheses, now we decide what to do. Is it a difference or it is a relationship? It differs from the two groups or three groups in the relationship. But yeah, but not as to tell what I said in the Okay, once again, I thank Devika madam and Gunnar sir for inviting me for this workshop and given an opportunity to interact with you. So, thank you very much, madam, and the management of Sharda. And the focal point of today, the audience are you people. I know it has been technical, but there is nothing wrong. Being a psychologist, if I can learn something, why can't you? One mantra. Even if you don't love someone, doesn't matter. Love statistics, it will not leave you. My experience. My wife says you love statistics more than me. It has never left me. So, with these words, again, thank you all.
That was definitely the most fun session so far, sir. Thank you so much. I would like to extend my thanks on behalf of PG Department of Chemistry, Sharda Plus College, Mysore. I request our principal, Madam M. Devika, to felicitate the guests. Sir. Lastly, I would like to thank everybody for being patient and following me throughout the day. Now there is a tea break arranged outside so you can have your tea and suspend this workshop. Thank you everybody.